Okay, using L'Hopital's rule again. This one's going to take a little space and a couple of derivatives. So what we want to notice right off the bat is that when I get close to 0, what happens is the e to the 7 over x number, so this guy right here, goes towards infinity. Okay, 7 divided by a number really close to 0, so 7 divided by 0.0001 is really large. Okay, that's 7 times whatever that decimal is as a thousandths or 10,000ths or whatever. So as we get closer to 0, 7 is going to multiply with a number that's increasing in size. So it's going to be e to that power, goes to 0. This guy right here goes to 0. So I've got infinity on one hand, 0 on the other. So here's infinity, here's 0. And then a number that's really, really close to 0 divided by 2. Well, basically what this is going to give us is the indeterminate form infinity to the 0 power, which we can't work with. So what we're going to do is we're going to take the natural log of both sides, or take the natural log of this, and we're going to use the rule where f of x, if we let, let's see, I want to write this down exactly right here. We just did it on the previous problem. So let me get to L'Hopital's rule to write it correctly. The limit as x approaches a of the f of natural log f of x is, if this is equal to some limit, then what we're going to end up with is the limit as x approaches a of f of x equals the limit as x approaches a of e to the natural log f of x, which is equal e to the L. Okay, so the only way to get out of this situation is to take the natural log. I'm not going to work with the limit right now. I'm just going to look at the natural log part, and it looks like this. Okay, now one of the things that we can use about a natural log is we can go ahead and take the exponent in the top up here, this exponent, he can now come to the front of the problem, and we can rewrite this guy. So this is just using the law of exponents and logarithms, and it looks like this. All right. From here, we're going to actually apply our limit rule, and we're going to look at the limit as x approaches 0 from the right-hand side. When I put 0 in, I still get some of that same. So now I get 0 times all of that, which is 0. Okay, so this indeterminate form isn't quite established yet, but I can't really put 0 in because it's still kind of a little on the wacky side. So what I'm going to do is rewrite this as a fraction. Okay, but I'm going to use the x over 2, and I'm going to divide by that reciprocal, because that allows me to get into an indeterminate form. So this is a step that we take every now and then. It's not really a common one, but what it does is it changes my problem so that I look like this. I have the natural log of e to the 7 over x plus 3x divided by 2 over x. Okay, the reciprocal of x over 2. This is where I'm at. So now what do I do? Well, now I can use L'Hopital's rule to try and get rid of the indeterminate form that I now have. Okay, I've got infinity over infinity here, so I'm going to take the derivative of the top and bottom. And to do this, I'm actually going to work under problem 13 because I don't have a lot of room here. So I'm going to let f of x equal the natural log of e to the 7 over x plus 3x. And the derivative of this is going to be 1 over e to the 7 over x plus 3x times the derivative in the denominator. Well, the derivative of any e thing is e to whatever the power is. In this case, it's 7 over x times the derivative of 7 over x. And so when I look at that, if I look at 7 over x, that's the same thing as 7 times x to the negative 1. And the derivative of that is negative 7x to the negative 2. So that's what I have here, negative 7x to the negative 2. The derivative of plus 3x is just going to be plus 3. And so F equation becomes e to the 7x times negative 7x to the negative 2 plus 3 over e to the 7 over x plus 3x. Now, I know this doesn't look too favorable for us, but just hang in there. Next is g. G of x is equal to 2 times x to the negative 1. Okay, see what I did there? And then g prime of x is going to be negative 2x to the negative 2. Okay? All right, back up here to this guy. We have a change in our problem now because we've taken derivative. And so I end up with e to the 7 over x times negative 7x negative 2 plus 3 over e over 7x plus 3x. And then times 1 over this guy divided by negative 2 to the 2x is the same as multiplying by the reciprocal. So I still have in the denominator negative 2x negative 2. Okay. And again, when I try and sort this out, I still have a function that is not going to allow me to just directly substitute in a 0. Okay. And so what I'm going to do is clean this up just a little bit. All right. So if I have negative 2x to the negative 2, remember, this is saying negative 2 over x squared. All right. Maybe that'll help. I don't know. But what I do know is if I have this in my denominator, let me write it again. And then here goes this first guy, negative 2 over x squared times 7 over x plus 3x. All right, so I can multiply by the reciprocal of this. I can multiply by the reciprocal of that. So that becomes x squared over 2. So the 2 wouldn't move, but the negative x squared could go to the top. That'll give me a new top. So negative x squared times negative 7x to the negative 2. Those cancel. Times e to the 7 over x plus 3. All that over 2 times e to the 7 over x plus 3x. And when I distribute, what happens is the negative x squared here and this x squared here cancel out. Okay, they cancel each other out. They're gone. And that just basically leaves me with a positive 7. So 7 e to the 7 over x plus 3 divided by 2 e to the 7 over x plus 6x. And all I did right there was distribute the 2. And so notice that the leading parts have the exact same setup here. That's too dark. That's too dark. Let me lighten that up. These two guys have the exact same power. Okay, they're going to grow at the exact same rate. So when that happens, all I have to do is look at the leading coefficients. And the leading coefficients are 7 over 2. So this guy then, following the pattern we wrote up here in blue, is going to end up equaling e to the 7 over 2 power. Now that's a lot of work on that guy, and there's some intuition you have to take. But be patient, practice it, and ask questions if you don't understand.